Hello and welcome to the next in this series of videos on wired and wireless networks. Today we're going to take a closer look at network architecture. So here's a quick overview of the objectives and outcomes for today's lessons. Hopefully by the end of this you'll be able to talk about the key network architecture layouts that we need at GCSE level. So what is a network architecture? Well, it's simply the layout or the organization of a network. There are two main types of architecture we need to know about at this level. We've got the client-server model and the peer-to-peer network model. Starting with the client-server model. Here we have a network where one computer, known as a server, provides data for many other computers, known as the clients. So you can see in this diagram here we have the server. That is a more powerful machine. This is where all the information is located. And then we have the various clients that access the information on the server. A server is typically a high-end computer which is designed to allow multiple users to access it. So over here we have a kind of classical picture of a server. We have lots of room for lots of secondary storage, lots of racks of hard drives. We've got lots of network connections, and this is a pretty powerful system. However, a server can be any type of computer as long as it's running the right type of software. So we could be talking about a desktop or a more powerful kind of souped up version of a desktop, sometimes referred to as a workstation. For larger corporations, especially large businesses that have a lot of traffic on the internet, they might want to use a more specialized server like the one in this diagram. The client-server architecture is the primary way local area networks are organized. So that's what you're going to find in a typical office, a typical school, or a typical university. It's going to be the client-server network model. The server typically looks after logins and security, file handling, printing, internet access, and similar functions. There may be more than one server on a network. You could have different servers with different specialized roles. So for example, you might have one server for your email. You might have another server just for the database. So often in these diagrams, you'll see one server and many clients, but you could have different servers with a specialized function, especially in big business. A user has to log in with their username and password before they can use the network. The server checks that the username and password are correct. And this is what we call authentication. So authentication is when we check that the username and password of the user are correct and valid, and that that person has access to our client-server network. Of course, we're all familiar with this. When you log in an office or a school or a university, it checks that you are the person you say you are first before you have access to the network. After a successful login, users can gain access to resources stored on the server. Often, they will have some storage space on the network for their own files. This is usually private and cannot be accessed by other users. So when you log in from the client computer, you can access the data and information and services stored on the server. You'll also usually be given some sort of storage space to store your own documents and files. These will be invisible to other users, hopefully, so that you have private access to them. The client-server network model is also the basis for the World Wide Web, the largest wide area network in existence. Here we have web servers. These are powerful computers that interact with remote users who access them via their browsers. The web servers deliver HTML pages, CSS style sheets, and scripts to the users, as well as other documents and files that they're interested in. So on a wide area network such as the internet, the client-server network works in a fairly similar way, except instead of obviously being in the same small geographical area, you're accessing a web server that's somewhere on the internet. So here you have a web server, maybe this is Google or Facebook or somebody like that, and this is your computer, and via the internet you can access the information stored on this server, which can then be sent back to your computer. Typically this will be a web page, but it could be a document, a streaming video file, or something similar. Moving on from client-server, let's take a look at the peer-to-peer network architecture. A peer-to-peer network is quite different. It is a distributed system where functionality can be divided among many network nodes. So this is a clear difference from the client-server network model, where you have one computer where all the information is stored and the lesser important client computers to access it from the server. Here, all the computers, all the network nodes have a joint function. They can act as client and server at the same time. So with a peer-to-peer network, there is no central file server. Instead, the files are stored on the secondary storage devices of each computer. In a peer-to-peer network, all computers have equal status. All computers can act as both servers and clients. So again, we can just contrast it here with this diagram. If we look at a client-server based network model, we have the more important server in the middle here, and all the clients are accessing the information that's stored on the server. So clearly, if that server stops working, then all the access to that information is lost. However, if we look at a peer-to-peer network over here, we can see that all the computers can act as a client and a server. They all communicate with each other. With a server-based network, if you have an important file, it is located on the server, and then the client computers can access it all from that central location. However, with a peer-to-peer network model, you might have part of that file on one computer, part of it on another computer, part of it on another computer, and then that can be shared around all the other computers on the peer-to-peer network. Peer-to-peer networks are easy to set up, but their democratic nature can lead to chaotic working. So this is specially focused on the idea of using a peer-to-peer network in a local area network at the moment. Security is hard to implement, and network performance can become unpredictable and slow. Keeping track of data and its updates can be difficult, and maintenance routines such as backups are also difficult to keep track of. Again, when you're using a client-server network model, the server can update all the computers on the network quite easily. It can back up copies of all the data. If you want to make a further copy of the data, you just need to copy what's on the server. You don't have to worry about the client computers. But with a peer-to-peer network, all the files are divided around the whole network. There's no one point that you can back up all the information easily. You'd have to back up from each computer on the network. You've also got the problem that peer-to-peer networking is generally only suitable for small LAN installations. So typically we will refer to that as 8 to 10 computers. If you've got more than that, running a peer-to-peer network gets very chaotic, becomes very difficult. You're probably better switching to a client-server model. Again, that's looking at local area networks. On the internet, we can also use peer-to-peer architecture because it's useful for sharing lots of files without the need to store data on a central server. And I'll just add the F in there for another little spelling mistake. Really have to read these through more carefully. Online communities make good use of peer-to-peer networking, such as enterprises involved in things like software development and distribution, because it makes it easy for them to distribute their product to many people without having to maintain their own server. So for example, if you want to share a new version of Linux, you can share it using BitTorrent. That means you don't need to have perhaps hundreds of thousands or millions of people accessing your server. You just make it available, and then that version of Linux is now on lots of different computers that can share that information with everybody all over the world. So it's a very economical way of sharing your data. However, peer-to-peer activity on the internet has led to much illegal file sharing and copyright infringement. So while some people use BitTorrent for perfectly legal uses, for example, sharing distributions of their new software that they want to make available to lots of people, it can also be used to share movies, computer games, and other sort of files illegally breaking copyright. It's very difficult to stop that happening on a peer-to-peer network because there's no one point that you can stop. With a client-server network model, you can just find the computer that has the data on it that is breaking copyright, and you can stop that server. But with peer-to-peer, that movie, that software is distributed across many computers around the internet, and you can't really stop them from sharing that information. So that's why BitTorrent is such a problem for authorities when it comes to file sharing. So we've got a little table here just comparing and contrasting the client-server and peer-to-peer network models. You can pause it, make some notes, have a little read through, make sure you're clear about all of this. So to sum up, the layout or the organization of a network is called its network architecture. A client-server network architecture is a network where one computer, the server, provides data and services for many other computers known as clients. A peer-to-peer network is a distributed system where functionality can be divided among many network nodes. So I hope you found that informative and useful. Good luck with your studies, and I'll see you in the next video.